derivative.
Okay, so we are given the graph of the derivative. We are in our review, we are going, you are in your workspace. Graph of the derivative. Okay. In the multiple choice, let the multiple choice lead you. What do you see? What words do you see from your forever cards in the multiple choice?
Concave
down,
increasing,
increasing,
minimum,
relative, and inflection. Okay, to think about all of those, don't we kind of have to think about the signs of the first derivative and the second derivative? Right? And the critical numbers, etc. Okay, if we were to take this graph and make a first derivative sign chart, if we were to, my question to you is, what would be the critical numbers of f?
Zero.
We have to do the zeros. We could call that one A, we could call that one B, we could call this one, well, we know that one's 16, right? We have A, we have B, and we have 16. Okay, question. What is the sign of the first derivative to the left of A?
Positive.
Because the y's are above. Because the y's are above. So we're going to have a positive. Where are the y's in between A and B?
Negative.
Below. Does that make sense? We're just looking at the derivative at above or below. So we can say above, we can say for all of these below, aka a negative derivative. For all of these, they're above the x-axis. And for all of these, they're also above. That would be my sign chart. So that means I have an increasing first function or f function, a decreasing first function or f function, increasing, increasing. Can we narrow down any of these?
A. Just no.
Well, we haven't even talked about concavity specifically. But if you see this, can we say that it's concave down the whole time? Does that even make sense if it's... No. So yeah, you're right. We can take out A. We'll talk about second derivative in a second. Is f increasing the entire time from negative 8 to 8?
No.
No, because I have some negative and some positive. So therefore, that would be a no. Do I have a local min at negative 8? I have a local min, but where is it?
That's at B.
It's at B. It's here. It's not there. F prime has a local min. But F doesn't have a local min until this point right here where our F changes. So therefore, that's no. So what's going on?
Oh, we're kind of
I mean,
options.
Narrowing down, the answer is probably D. But what? If we were to do a second derivative sign chart, don't I need my pips?
Yes.
And what are my pips? My pips are when the second derivative
Is zero.
is 0. How do I visualize a second derivative from a first derivative graph?
You're asking me.
Not the curve. It's the curves of f. It's the slopes of f prime. The slopes of f prime are f double prime. And then the above and below of f prime are the signs of f prime. Here's my hint. The above or the below of f prime are the signs of f prime. And then the slopes of f prime are f double prime. So my question to you is, are there any places where the slopes are 0? And where is that?
Negative 8, 8, and 16.
So where the f prime has horizontal tangents, f double prime has zeros. And how do I check the signs of f double prime? Well, is f prime decreasing or increasing? Are the slopes negative or positive? What are all the slopes before negative 8?
Negative.
The slopes are negative. F prime is decreasing, so therefore, that's how I know f will be concave down that interval. What are the slopes in between negative 8 and 8? Positive, or f prime is increasing. That's how I know concave up. And then it goes,
Down.
f prime is decreasing, so I know f will be concave down, and then f prime is increasing.
So that's how you know that that's an inflection point.
Inflection point at 16. If I were you in some sort of colored pen, I would write this little hint down in your workspace and peek at it. Maybe again before tomorrow. Tyler, go ahead.
Don't the slopes of f prime start to decrease from 0? Like
they start to, the slope value starts to decrease, but the slopes are still positive, aka f prime is still increasing for slower.
Oh, okay.
F prime is increasing slower. So you'll be talking about the triple prime. Okay, to that end, you guys have that little FRQ close, right? Go ahead and peek at the FRQ and look and see why I gave it to you. Look and see why I gave it to you. Let me skip ahead. Look and see why I gave it to you. What are you given?
F prime.
Are things labeled a bit more precisely?
Yes.
Yes. They tell us this is a graph of f prime. They tell us there are horizontal tangent lines at -3, at 2, and at 5.
Oh, that's good.
Okay, I'll fix it over here. And they also tell us we have a vertical tangent at, a vertical tangent, that's interesting. Guys, what's the slope of a vertical tangent?
Undefined.
Undefined. Okay. Relative min, tell me what you know about a relative min.
It's where like when you do a sign chart, it's where the slopes go from f prime goes from a negative to a positive. Therefore, the function goes from decreasing to increasing. So you kind of swoop up.
Have a 0.
Okay, I think I'm writing what Sean is saying, so then there are a couple blanks you still have to fill in. What's the sign change of the first derivative to get a min? Follow the flow. To get a min,
Let's go from
negative
to
to positive. Okay. According to your forever card, you could look at it on the test. The first derivative test says f prime must change from negative to positive, but what's the beginning of that forever card step? At x equals c, which is a
0.
critical number. And a critical number would be a 0 or a DNE of f prime. Question, does f prime have any zeros or DNEs?
Yeah.
Where are its zeros?
It's where it's
like
it's where the
negative 5 maybe that is.
Negative
I
5,
think of 1, I don't think.
negative 1,
Oh shoot, is that 5?
and 5.
Okay.
Negative 5, negative 1, and 5. So I do have zeros. I'm going to set equal to 0, or you could also say since it is a critical number, or since there is a critical number there, and you could put it that way also. The question, which of those zeros, negative 5, negative 1, or 5, it could be 1, it could be multiple, which of them have the sign changing from f prime, of f prime, from negative to positive?
negative 1.
Yes, because, remember, below is a negative, above is a positive. Here's my signs. F prime is positive, F prime is negative, F prime is positive, and F prime is positive again. So where in a sign chart, if I was to make it, is there going to be a change from negative below to positive above of the derivative at negative 1? Do you guys see how I basically used my forever card? And then I kind of filled in where was the right spot? How about letter B? Find a relative maximum.
Oh, so we do the same process.
Same
but
process, except what are we going to change? Don't give me the answer yet. Relative max,
We're going to change the last statement from positive to negative.
since, and we have zeros, so we're going to say, okay, f prime is equal to 0, and for a relative max, yeah, changes from? For a max, we had a min, now we have a max. That's going to be positive to negative, right? Okay. So which 0 does the graph change from above to below? Negative 5. Are we kind of getting the above, below is the sign of the derivative?
Wait, for 8, you said would 5 also be a relative?
Why not? Who can say why 5 is neither? Sean.
Since we're looking at the graph of F prime and we need a sign change, there is the positive to a positive. When you're doing your sign chart, it looks like up and up. You don't have that little
So there's no
curve.
going down and there's no, yeah, does that make sense?
Yeah.
So since it goes from above to above, F prime will be positive to positive, no sign change. Does that make sense? You guys already looking at letter C?
Mhm.
What's letter C talking about?
Concavity.
Concavity, if we had F, which we don't.
It's F double.
It's F double prime though, you're right. Okay, look at your hint in your workspace. Look at your hint in your workspace. You're supposed to write it in pen. How do we think about if we have F prime, how do we find or consider F double prime? Slopes. The increasing, decreasing tells us the sign of the slopes. So question, when will the slopes of F prime be negative? Hence, when will F prime be, can you guys attach it? If the slopes are negative, what's F prime doing?
Decreasing.
Decreasing. Does that make sense?
Negative
Cool.
first, like,
Where's
so,
F prime decreasing?
From
everything
from
before
7
negative.
Negative
to-
7.
Negative 7 to negative 3.
Yeah, good.
And then also from like, I don't know,
2 to
positive
3. Open interval because
5.
that's it becomes vertical and it doesn't exist. And then from 3 to 5.
And the slope, can you guys see the slope at negative 7 is technically going to be a 0? Does it look like it's leveling off at negative 7? Okay, so we're going to make it open at negative 7 since the slope isn't negative there. But after negative 7, it starts decreasing all the way, you're right, negative 3. The slope is 0, so that's not negative, so I make it open there as well. But you guys did notice there is another place as well, right? It starts decreasing at, is that 2? All the way to 5?
No, not all the way. Because you can't
Why
say it for the vertical asymptote.
Okay.
Because it's undefined.
So we're going to go from 2 to 3, and then from 3 to 5. Because at 3, there's a vertical tangent, which means the slope is undefined, so I have to split up there. So the same reason I have open at all the zeros, because it can't be negative on a 0 or at a 0. Same reason I'm open, I also have to make it open at the vertical tangent. Good catch. That was tricky. But otherwise, you guys get it. It was decreasing for those intervals, right? Okay. Letter D. It doesn't even say justify. Sweet, go team. Absolute max, guess what? We can't do. So hold on, I want you guys to change something for me. Ready? At what value, or you could say values, does F, I want you to change it for me. We can't do this without integration. Does F, change it, cross it out, have points of inflection?
Well, yeah.
Just trust me, you can't do it yet. Because it's asking
I
for
believe.
F's absolute max. Not F, not F primes. So we would need to think about integration. How do we think about F and how it's moving and changing? And we would have to know actual number quantities for how it's changing, not just ideas. The sign chart tells us ideas. We know that F is increasing, then decreasing, then increasing some more. Maybe if you think about it's increasing and increasing some more, it's going to be highest here, but we're not going to be thinking about that right now. That's technically second semester. Absolute max, we only know how to do it, section 3.1, if we have F. Do we have F?
No.
No. So don't worry about absolute max unless you have F, and we'll talk about that before today's done. Instead, did you guys cross it out? Please, please. Okay. Where, it could be more than one, where does F have points of inflection? Define points of inflection. You can look at your forever card. What's it
Where
say?
F double prime of X is equal to 0 or undefined.
And that's possible.
That's possible.
Pips are when you have zeros or undefined.
Maybe how
And
concave I mean, the F double prime have
they have
sign
there's
Sign change of F double prime.
Yeah.
Do you guys get it? Put it together. F double prime is 0 or DME, pips. That's a forever card, right? Points of inflection, possible and actual, or you could call them true. You can call them trips, right?
Yeah.
True inflection points. Okay. So we have our possible ones from the zeros and DNEs. So where is the slope? Slope. Where are the slopes of F prime, 0 or DNE, and the sign of the slopes changing? the signs of the derivatives changing. So we have don't we have our zeros and our DNEs right here, already marked?
Yeah.
Yeah.
Okay, we already have our possible marked.
So we have to look at the sign of the slopes, are not necessarily signs of the F.
As you guys look at your graph, let me just fill in the forever card. Points of inflection at x equals since. You don't even have to know the answer yet to start writing. Since f double prime equals 0 or DNE at these points, and f double prime changes. I guess I could have saved at these points for later, huh? And f double prime changes sign. That's what Charlotte was saying. You have to have a sign change at these points. Now, depending on what we choose, we might take away the DNE if it's not 1, but okay. In order for the f double prime to change sign, f prime has to change from increasing to decreasing or decreasing to increasing. The slopes must change sign. So where are the slopes changing sign? Anybody found one yet?
Yes.
Where?
-3.
Good. I have f prime decreasing before and increasing after. The slopes are negative before and positive after. So yeah, -3, that's 1. Is there anything else?
2.
At 2, f prime is increasing then decreasing. Slopes are positive then negative. Good. And 5. Why not 3?
Because we still have the negative to negative.
So I'm going to go ahead and cross out the DNE. We only used the zeros because the slopes only changed at the zeros. Here, it was negative before and negative after. F prime was negative before, negative after. That would not work. F prime was decreasing before, decreasing after. Guys, excellent job. Excellent job. In section, I think it was 3.5 or even 3.4 or 3.3, they gave you some different problems where you were dealing with graphs of derivatives, right? So I wanted to, since it's a tricky type of problem, and I can promise you now there's one long answer similar to what we've done today on this F prime item. Make sense? Okay, the FRQ to study and the practice problem. Okay, let's pause for just 1 second. Section 3.5, when you guys were doing that, when you guys were doing 3.5, what ideas did it review?
Crits and points of inflection.
Everything. Now, I did mention that there is going to be a problem similar to this, or I guess it's similar to all of them. There is going to be one 14 identifies problem at the very back page. Your test tomorrow is 2 pages, both front and back. The very back page is one big one of this. But I give you all the categories. You just need to fill in. I don't give you the derivatives, but I give you a function similar to this. I give you all of this written out. It's the whole back page. I just have x-intercept is blank, y-intercept is blank. I give you all of it. You just need to remember how to find each of them. Does that make sense? So there's one 14 identifies tomorrow, but it has you review some pre-calc. But then it has you review critical numbers are zeros, DNEs of the first derivative. Increasing, decreasing, test, use the domain to know how much of a number line to make. Put in your critical numbers and any domain problems. Test before, test after. That's why I'm probably going to let you have your calculator, just so that you're not doing like subtraction errors and it's messing you up. Does that make sense? Extrema, look at the flow. Pips, zeros, DNEs of the second derivative. You guys will have to find the derivatives, but I will write it all out. You don't have to memorize the 14 identifiers, okay? Sound good? Okay. But section 3.5, guys, it reviews 3.4, it reviews 3.3, it reviews 3.1. What does it not review?
3.2.
3.2. So let's do a little bit of mean and rolls. Is that okay?
Okay.
Stay in your workspace. Let's go ahead and change it. Change the title. Let's make it MVT and rules practice. Let's do like a little bit of practice. Oh wait, practice. Practice multiple choice. Where am I right now?
In the
Class folder. Oh,
Okay.
handouts.
I'm going to answer Tyler's question in just a second. You guys are titling MVT and rules practice. But why don't you also say and absolute extrema of practice? 3.5 doesn't review absolute extrema. There is a forever card on all of these things, on MBT, on rolls, and on absolute. But we're going to go try to find just a practice problem here and there of absolute, MBT, and rolls because we haven't reviewed those in a long time. Tyler, you had a question. Everybody else look up here. Where am I right now? Tyler, go ahead.
Oh, what was the answer to D?
To D or B?
D on the last one.
Oh, can you guys help out?
FRQ.
The answer
No,
is
no,
D.
no, on the FRQ.
Yeah, it was negative
No,
3,
no.
2, and 5.
No, the D you crossed out.
Oh, it would have been at the end point. It would have been side. Because the positive area from wherever it starts to wherever it ends overrides the negative area.
Sure.
Okay. Guys, what do you see? Chapter. Woo-hoo-hoo! I've just made separate files for the practice test. That way you don't have to go looking at the end of the notes. Because some of you guys, I think it was too hard for you to go to the end of the notes and find it. And so you didn't. I have the practice test answer key and the practice test right here. So we're going to go ahead right now. We're going to go find some questions. These are just practice multiple choice. Practice multiple choice. Practice test. Okay? Let's go find some that have MBT, rolls, or absolute extrema. Woo, cool. But do you guys also see in your folder? There are all the answers as well. Are you gonna memorize them all? I wish I had a brain that would memorize them all. I don't. All right, kiddos. Critical numbers. Don't tell me how to solve necessarily. Critical numbers. Ooh, that's F prime pitchfork, right? Okay. Ooh.
We won't need a
Be
picture.
careful simplifying. There's going to be
There's gonna be
shared stuff. We're going to come back to that one. That's a good one. Okay, number 2, absolute extrema. Here we go. Number 2, absolute extrema.
On the interval, miss -4.
Oh, gosh.
That's
It looks nasty, right?
She nasty. She is nasty.
It's
just a polynomial, but it's just
Question.
disgusting.
Question. Isn't the top bigger than the bottom?
Yeah.
Let's divide.
Yeah. How do you know if it'll go in evenly or not? So you have your calculator tomorrow.
As we
I don't
can.
remember.
Or longer.
0 over 0. Couldn't we plug in -4 top and bottom and see if it goes in? Because what are you guys scared of? What do you have to do? Step number 1 for absolute extrema.
Pitchfork.
You have to pitchfork the derivative. Yeah, critical numbers and endpoints according to your forever card. Absolute extrema. We need to think about critical numbers and endpoints.
Oh wait. I'm
Not for
thinking rolls.
absolute
I'm
max.
thinking
It doesn't need to be continuous on the interval. Is it continuous on the interval?
yes.
Because they don't include -4. So it is continuous on the interval. It's not closed, which is why maybe one of them won't really exist. Technically, if you have a calculator, you could graph it, but that could get a little messy. Okay, has anybody plugged in -4 yet? A lot of your calculators, there's been ample time. No one's plugged in. You guys are killing me. Tyler, give me a calculator.
Oh.
Gracias. Why am I trying to see if -4 goes in? Because if we can divide, wouldn't that be way easier to take the derivative of?
Yeah.
So -4 cubed plus 8 times -4 squared plus 19 times -4 plus 12. Guess what?
I assume it's 0 because
It goes in.
probably would have been like aw stink if it wasn't.
Yeah. You know me so well. I'll stink, I'll poop, something like that. Alright, so I'm going to go ahead and quickly divide, and the reason is we don't want to take a derivative of something nasty if we don't have to, right?
Could we do synthetic for this?
Yeah. You want to do synthetic instead?
Yes.
Can we do both?
Sure. I started the long division. Keep going.
I'm going.
Synthetic. I'm putting in -4 with 1, 8, 19, and 12.
Carry
I have 1,
and 4.
I have 4,
16,
I have 3.
Yay.
So what can I say this is? X squared plus 4x plus 3 such that x can't be -4.
Yay.
Okay. We need critical numbers, right?
So
So it's time to take
wait. So we have to take
Minus 0.
of the derivative. Who's the derivative of x squared plus 4x plus 3?
2x plus 4 plus, oh,
I set that equal to 0. What's my critical number?
Negative 1 time.
-2.
Wait,
Be careful.
2, yeah.
Whew, gotta be careful with algebra tomorrow. -2. 4, absolute extrema. What does your card say? We need to test.
Is there another?
Nope, not sign chart. Absolute extrema.
Oh,
Not the number line.
It's relative.
So
You can
is
have a
greater
curve.
than, right?
Yeah, absolute extrema was underneath EVT, the extreme value there. EVT, and absolute max and min will occur, and they will always occur at
Critical numbers.
critical numbers or endpoints. So I'm going to plug in, what's the first endpoint? -4. Wait, I'm making that in parentheses because is it actually allowed to be there?
No.
It's going to be a hole. But we'll still check them and see how high that hole is. Then we have a critical number of -2, which is in between, which is why I put it, and -1. Where am I plugging it in?
In the original?
How high is that y, remember? How high is that y? We have to figure out how high is your y. We have to check each of them in the original. Good, Sam. So in the original, can we plug it into the mess? Sure. But can we plug it into the easier version? Let's do that. If we plug in -4 squared, that'd be 16 minus 16 plus 3. The whole is at -4, 3. Plug in -2. That'd be 4 minus 8, -4, plus 3, that'd be -1. I'm plugging it into the original, right? Okay, anybody plug in -1 yet?
1 minus 4.
1 minus 4 plus 3, that'd be 0.
-2.
So what is the correct answer?
There is the absolute max. But if it's a whole, no. No max.
What
should
we
be
see? I think it would be -2.
So A?
Why can't I say that there's a max?
She ain't real.
It's a hole, it's not real. It's gonna be an empty circle. Same reason here, pause, look at number 3. Can I say there's an absolute max at B?
No, because it's a hole.
There's a hole. So if there's a hole algebraically, same thing as if there's a hole graphically, I can't have a max there. But that would have been the max, right? Which is why I say, oh, none, because what would have been the max is missing.
Wait, but doesn't it count because it's not in the square?
But remember, how do I choose it? -3.9? Well, I could do -3.9 and -3.9. So like with the graph, even though it's not included, I can't pick a highest because it'll get infinitely close or infinitesimal. Good, good, good. So what would you guys answer for number 3 since we're here?
A?
Wait, hold on. I read it.
3.
In the graph
No, maximum.
with possessive extrema.
D.
Absolute no max.
Yeah,
Right.
I agree.
The max is missing.
Okay.
The max is missing.
Is the minute thing?
No max, there's a minute A. Except, ooh, what did you guys miss?
D?
Is oh, we're on. Oh.
What did you guys miss?
Oh my god, so.
You're right with the no max, but if you can't include that,
It's not.
Oh my gosh, so there's no.
that would be.
So no extrema.
No extrema.
Wait, haha, you got bamboozled.
But some of you did get half of it. You're right, no max, there's a hole there. There wouldn't be a max no matter what, open or closed. No max no matter what.
Oh.
But since that was open, it says you're not allowed to include him either. Well, then no man either. You took away my max and my min.
Hey, you come fight through.
Okay. Kiddos, we have not done MVT or rolls. Let's keep looking.
That's what I haven't.
Who's that?
That looks like an average rate
Oh,
of
that's
change.
It is an average rate, equally instantaneous rate.
Therefore,
Turn to your
mean value
MVT.
theorem.
It is MVT.
There will be a point in which the average rate of change will equal
Now,
the
this one
instantaneous.
gave you the formula for MVT. Let's just look really quickly. Does anything give us just
Set
words for
prime.
MVT? MVT, that's like a derivative test, points of inflection. Or is it, ooh, what's on the last note, but we have numbers, increasing. Ooh, determine why it does not
Calculator may
apply.
not be used.
Continuous and differentiable.
And 0.
And
This one gives me the formula 2. Oh, that one gives you the formula 2. Okay, so these are kind of nice. They're giving you the formula. But even if they don't give you the formula, you guys are going to be able to cheat and use your forever card to have the formula, right?
F of A minus, no, sorry, F of B minus F of A over B minus A.
Alright, so let's go ahead and go to number 4. How do we solve with the formula?
Okay.
First of all, can we use, let's review, can we use MBT? What are the 2 conditions that have to be true?
Continuous in the open interval.
Okay, so is this continuous on, what's the interval? 2, 7?
Yes.
Wait, continuous, I need my endpoints, remember? Not
As long
open,
as,
continuous is on the
closed.
closed interval.
But the
I need my endpoints, differentiable is on the open.
Yeah, it is, because it has to be 0 to not be, and it's true.
Okay, so Tyler's looking at the function saying, wait a minute, domain x can't equal 0, but is 0 a problem from 2 to 7?
No.
No. Good. So continuous, check.
Okay.
How do we check differentiability?
Derived.
Let's just
Take the derivative. So then the derivative, which we need anyway, don't we?
Yeah.
Mhm.
We need the derivative anyway. It's going to be 0. Do you remember how to take the derivative of, there are multiple ways. How many of you would use quotient rule for 14 over x? Okay. How many of you guys would make it 14 x to the negative 1?
Yeah.
Okay, that works. So, derivative of 9 is 0.
9 plus 4.
And then we'd have plus 14x to the negative 2, which make it easy on your brain. That's 14 over x squared. You good? So that's still not differentiable at 0, but is 0 a problem between 2 and 7? No. So then we have to go ahead and set f prime of c. Remember, take your derivative. If you want to, plug a c in. Take your derivative. X becomes a c.
Oh gosh.
How do I solve what's in that thing?
Maybe I'm,
That's averages, so we just take the
Go plug in
marginal.
stuff. Good. Take your 7 and plug in. 9 minus 14 over 7, 9 minus 2 is 7, I think.
Yes.
Plug in 2, the original. 14 over 2 is 7, 9 minus good. Oh. Okay. But we have to plug in,
Yay.
carefully. But 7 minus 2 is 5, 5 over 5 is 1. But guys,
Square root of 14.
this was a nice multiple choice.
Plus
Usually, 1 would be one of the answers. Usually, 1 would be one of the answers. But is this my final answer? No, no, no.
Because you have to
I need to solve this.
None of these equals 1. See if she did miss.
They weren't. That's funny. Yeah, that's not the right answer though. That's funny.
So
14 equals c squared. C is equal to?
Plus or minus.
wait, we have to think about our interval.
Good. They have it ready for you. Just calling it
Well, I was
like a
wrong.
siren to your destruction. Because you guys know I need siren.
Negative.
The siren in the ocean. Anyway, coming back.
Wait, what?
There you go. Sirens are like the destructive mermaids that would like call the sailors and they would like eat them or kill them or drown
Kill
them.
them.
Coming back. Why did Sean say wait?
It's not a neither.
I'm looking only is a negative. Anybody going to be in between 2 and 7?
There's a lot of circles.
Dun 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 dun. C.
I just have
Wow. Yeah, bigger.
Are you gonna get tricked tomorrow?
No,
No.
not my playbook.
Be ready. Be ready. Have we reviewed MBT? Yes. Have we reviewed roles? What's roles different, or how is roles different?
Just say
It doesn't have an average
Still
rate
needs
of
to be
change.
true.
is
That
equal to
still needs to be
0.
true, but it has number 3. What's
When
number
the
3?
average rate of change is equal to 0.
F of A has to equal F of B, which will indicate that average will equal 0. So hence you just take the derivative and set it equal to 0 instead. The nice thing is in these sample multiple choice that we were looking at, I think, I don't know what I just did, but it was bad. It's still
there she is.
Oh gosh.
Okay.
Oh, well, it's cool you can do that, but that's not what I wanted. Wait a minute.
We're under attack. Let's
I
go
memorized
for
them all.
it. Sarah! Sarah, you died!
My practice test is gone.
Come on.
Okay, but wherever rolls comes up, wait guys, you have your photo cards. You don't need me to show you this. You have your photo cards. Okay. Besides that, we reviewed absolute extrema at least a little bit. There might be some more here. There's definitely some in your review and or your notes for absolute extrema, 3.1, right? If you have a graph, be careful and remember, if you have a graph Can there be an absolute anything at a hole?
No.
But what if the hole's not included? Can we go one step before the hole and have the max?
No.
What if the min's not included? We can't go one step before, so we say no. Absolute extrema, 3.1. 3.2, MVT and rolls. The practice test is a great place to practice because as you saw, I think I saw 5 or 6 different MVT rolls practice problems. Are you going to have to be careful with your derivatives?
Yes.
And if you have any derivative questions, as some of you might still be finishing up 3, hopefully not too far back, 3 point something. I had one person email me last night. I did the quick derivative. I sent it to him. Hopefully it helped. We'll see in period 6. You guys have a review to do. Let me go ahead and pull it up really quickly. And as I do, does anybody have something that's been bugging them? From section 3.4, section 3.5,
Yeah.
a concept-y thing.
Is there any natural log or exponential thing?
Not in the 14 identifies, for sure. If
Are you happy most like?
If there is something earlier, it would probably just be a problem where you're trying to find like critical numbers or pips, like taking a derivative, and you will have your forever card formula.
It's so
So it
nice.
could be, but it's not going to be a big deal. Guys, remember why we're having our forever cards? What are you going to be doing over break?
Studying them.
Studying them. I'm going to have a nice little worksheet, a nice little handout that's going to explain how to study them over break for a grade right when you get back. It's going to be up at the front table tomorrow, so when you turn in your test, you have to pick one up. It's your homework for over break. And I might have like a little baby multiple choice just to see how you guys do with like some mixed multiple choice practice. At some point, try it. We'll grade it when you get back. But the forever card code, remember, there's going to be a forever card, a big quiz on all the forever cards when you get back. But that's okay, because you use them tomorrow.
Hey Gabe, or this is like your
If you guys want to write down the test, go.
they gave like F double prime. And
Ooh, the graph of that double prime?
And they wanted.
Tricky? Not tomorrow.
Oh.
So we could, but let's save it. We'll see some of that on like AP practice a little bit later on. But long story short, F double prime, if you're looking at F double prime, it's above and it's below. Tell me the signs of F double prime. It's zeros, it's intercepts, tell me the pips. Does that make sense? So it's zeros, tell me the pips, it's above and it's below, tell me the sign of F double prime, hence the concavity of F or the increase and decrease in F. Any other concept you want on through 4, 5? Yeah.
Giving you a graph and telling you to find the function.
Doesn't happen.
Giving you a graph of F or of F prime.
Of F and telling you the relative maxes and mins and inflection points and saying, go and find the thing.
Okay. If you had something like wait, is this that one with ax squared plus bx plus c or whatever that
You know,
is?
yeah.
That one. I don't think you do. What you would need to do on that is take the first derivative, second derivative, set equal to 0. Plug in the points they give you to the original function, because you could plug in x's and y's and get a system of equations. But not tomorrow. Not tomorrow. Any other ones? I need it as a concept.
So the graph has
Dude, let's go to
Yeah.
together.
Charlotte is reminding of us when we're trying to set up a sign chart for the first or second derivative. If we have domain restrictions, vertical asymptotes or poles, do they go in the sign charts? Yes. Can they be pause, points of inflection, or relative extrema? Discontinuities, can they be
Yeah.
mins, maxes?
No.
But do I still put them in the sign chart?
Yes.
Are they critical numbers or pips?
Yes.
No.
No. They're separate. They're separate. Remember, we put them in parentheses. We put them in the sign chart. We don't call them critical numbers.
yeah, but they
Because they're not.
他们就只有直接抄答案，不管你
抄不懂。
不管你基本上看图就直接抄答案。
你如果要真的要自己写作业的作业太复杂了。
So because it's not a cannot be
我学的，我抄的没错。
前面跟说的 cavity.
Still put it in like we always do. We always put in the sign check.
Also for the this one.
only when if these were flipped. If there's no flips.
Oh yeah,
This
yeah.
is not that
I
So close.
I tried to actually there's the old yeah, but I don't know like
Find me one, there will be one when the top is a polynomial of a degree 1 higher than top.
how would I like
Long division. Ignore remainder, but keep the rest. That line can be the not the second, but I can do the second. And then Charlotte, I'll put it on a board and have it ready for you.